Welcome. This video covers the basic ideas behind doing prediction. We're going to stick with that wine data set that we analyzed in the last video, but we're just going to change our goal in this case. Our goal here will be to use those properties that they derive from the wines to try to use those to predict the quality. And we'll just do some very basic modeling here. Remember that this is what our data looks like. We have this quality variable as our response variable. That's the thing that characterizes how well our wines are performing, i.e. how good they are. And what we might want to do is try to take these variables that we see over here and perhaps also the wine type and try to use those to predict the quality. Is there some combination of alcohol, pH, acidity, and wine type that I can use to get a pretty good idea about predicting the quality of my wine? If I can figure out an equation like that, maybe I could figure out how to make my wines in a way that they will have higher quality. All right, so again, that's our whole goal here. We want to try to do prediction in this case, not inference. And we have this idea that we have this larger overall group, this population of interest that would be all Portuguese wines that we could ever make or purchase. And what we want to do is try to use the relationships in our sample to try to either predict the average quality of wine for our population, or to predict a new value if I created a new wine. Where might I see the quality value for that new wine? So we sort of have two ideas of what we might try to predict. We might try to predict the average of all wines at a particular setting of these predictor variables, or we might try to predict the new value of quality at a particular setting of these predictor variables. And of course, when we do this, we're going to want to have error bounds so that we have an idea of how variable our prediction is. So a very basic model that we might try to use to predict our average quality. So here we're going to try to predict our average quality as a function of an intercept, which you might label as beta naught, plus a slope, which you might label as beta 1, times our alcohol variable, which you might call an x1, plus a slope 2, so that might be a beta 2, times a pH variable, so you might call that x2. So we're just trying to use our predictor variables in some form of a model to predict our average quality here. The question becomes, how do I actually get values for, say, my intercept? How do I get values for my slope based off of my data? How do I fit these models? Well, that's a whole another ballgame. We're not really having the time to talk about that here, but there's the idea of least squares, there's the idea of maximum likelihood, all things that you can learn about in our coursework. And then the other question is, once I fit the model and I use it to get a prediction, how do I get error bounds on that prediction? So how do I figure out that my prediction should be here, plus or minus some range of values? Well, again, at that point, you got to go to probability and statistics to try to figure out how to take into account the sampling variability and other variability sources to get those error bounds. Again, a bit beyond us, but we're just going to hope that we can get the ideas down for what prediction is trying to be, what we're trying to do with prediction here. All right, how do we actually fit this? Well, there's a lot of different procs that we could use to do this type of analysis that we're talking about. We'll stick with proc-GLM in this case. So proc-GLM stands for General Linear Model. General linear models just include regression models, ANOVA models, and a combination of the two. But basically, all I'm going to do is I'm going to use this model statement to specify that this is going to be my response that I'm trying to predict, and this is my predictor that I want to use to predict it. So in this case, I'm just going to use one predictor to try to estimate the response. And so the model that we're actually fitting here is given below, and SAS will fit the model using least squares / maximum likelihood. They give you the same thing in this case. And this would be the estimated fit down here. And that line is then plotted over here on our scatter plot. So this line is actually what you see given there. And we talked about the idea of having error bounds. And you might be able to see that there are dashed lines up here and dashed lines down here. So those dashed lines represent prediction limits. So those would be intervals around which we would expect a future observation to be found. So if I had an alcohol of 12 for a wine that I'm going to make now, whatever 12 means, here would be my predicted value for it, and I would expect it to fall between here and here in terms of the quality scale. That would be a 95% prediction interval for a future wine's quality with an alcohol of 12. There's also a very very, very small shaded line around here, which you can't hardly see here, but there's a shaded region that represents confidence limits, and the confidence limits, what that means is we're trying to capture the mean of all wines that would have an alcohol of 12, for instance. And so that's a much easier problem to do because we're trying to get the average of everything rather than just one future value. So that interval is very, very small around our line. But that's the basic idea of doing prediction, right? I want to try to take my predictor variables and put them into some sort of equation that's going to allow me to estimate my response. The big idea that you might have noticed here that comes into play in both the inference case and the prediction case is that there's variability in data, right? If I have one data set and I do this analysis, I have a second data set from the same population, and I do the analysis, I'm not going to get the exact same results. And so I need to be able to take into account the variability I see between samples. And that makes this prediction idea difficult, it makes the inference idea difficult, and that's the whole reason that we studied the idea of behind statistics. Statistics is what's going to allow us to account for that variability when we're doing our predictions and making conclusions. So the point of these two videos was really just to prepare you to look at the output and have an idea what we're actually trying to do when we cover some of these basic analyses that we're going to do in the rest of this module. What we're going to cover is correlation analysis. We've already seen how to calculate correlations for data, but we're going to look at how to actually do testing for them and confidence intervals as well. And then we're going to look at basic ideas behind simple linear regression and multiple linear regression as well.